Hello everyone. So in this video lecture, we're going to talk more about what DLT, distributed ledger technology is, and let's just get ahead into it. So first, what is actually a distributed ledger technology? Distributed ledger technology that goes by DLT, excuse me, is a digital system for recording the transactions of assets in which the transactions and the details are recorded in multiple places at the same time because it's all distributed out there. And unlike our traditional databases, distributed ledgers have no central data store. They have no centralized authority taking care of them. They're completely distributed, completely decentralized. And then coming to the next point, DLT refers specifically to the technological infrastructure and protocols that enable the simultaneous access, validation, and updating of records that characterize distributed ledgers. It works on a computer network spread over multiple entities, locations, or nodes. In a distributed ledger, each node processes and verifies every item, thereby generating a record of each item and creating a consensus on its veracity. A distributed ledger can be used to record static data such as registry and also your dynamic data such as financial transactions. Blockchain is a well-known example of distributed ledger technology because it does not have a central authority. It does not have a central person sitting on the top of everyone. It is completely distributed among different nodes participating in the network. Make sense? And then let's talk about the ledgers because distributed, we understood what do we mean by distributed. Now the next word that goes in is ledger. So what actually, ledger is? The origin of ledgers, it started way back in I don't know which of the time zones, which of the timelines, but it has been evolving since then from clay tablets to papyrus to telesticks, and then we came to the writings in the books, double entry bookkeeping, then coming to spreadsheets, and now finally to the distributed ledger. So let's just read about what we saw before. Ledgers, which are essentially a record of transactions and similar data, have existed for millennia in paper form. They became digitized with the rise of computers in the late 20th century. Although computerized ledgers generally mirror what once existed on paper. So what was there on paper, everything was put on the everything was put onto the computer when just computers came in, and that is okay. That is perfect. But that is long back, right? We need to make changes now. It has been years and years, decades, I would say, since computers have been found, since people have started using computers in their daily lives. So now we need to make a shift. We need to make a jump, right? So ledgers historically have required a central authority to validate the authenticity of the transactions recorded in them. For example, banks needed to verify the financial transactions that they process. Now, 21st century technology has enabled the next step in record keeping with cryptography, advanced algorithms, and stronger and near ubiquitous computational power, making the distributed ledger an increasingly viable form of record keeping. So, this is all setting up the foundation for for how your distributed ledgers come in play, right? With this, the slide that shows you what used to happen when we used to have a centralized ledger. If buyer is actually buying something from the seller, buyer will make a payment, then bank will authorize the payment telling that okay, buyer's account -1, seller's account +1, and when it's +1 we tell the seller that hey, the payment has been made. But now it's all about mining. It's about 51% of the people agreeing that your transaction is valid, and then it is considered valid, right? So with coming to this, we have a formal definition of DLT that goes by distributed ledger technologies, DLTs, the most prominent implementation of which is blockchain, enables large groups of nodes in the distributed ledger networks to reach agreement, that is consensus, and record information without the need for a central authority, that is decentralization. So you get it. Distributed ledger technologies has two important parts, and those two important parts are same for the blockchain as well. And those two important parts, what are it? It should be decentralized. We need not to have any central authority governing everything. And second, all the nodes in the network need to reach to an agreement, need to reach to a consensus to tell which transaction is valid and which one is malicious transaction. Now that we know what DLT is, let's see how it actually operates, right? So a distributed ledger is basically a shared, a replicated and synchronized record system. Instead of being, logged and kept away in a central database, copies of the ledger are spread across all the nodes in the network. So let's just see how the process works step by step. First, it is the nodes in the network that are there in the network can talk to each other directly. There's no middleman, every participant is just part of the communication. Second, when a transaction needs to be added, nodes propose it. Special computer programs then help manage this process, making sure that the proposal is structured, proposal is ready for validation. And third comes your most critical piece, that is the consensus mechanism. This is where the network collectively decides whether the proposed transaction is valid or is invalid. And if the nodes agree, the transaction gets added to the ledger. If they don't agree, they don't get added to the ledger. Now, if we talk specifically about blockchain, which is a very important use case of distributed ledgers, it has a unique feature. Instead of, simply storing the data randomly, it stores data in groups called blocks. And each new validated block is then cryptographically linked to the one before it using the previous hash. Right? You remember everything from that? Then we have a Merkle root also. And all of this complete secure network that we're going to make, the unbreakable chain of records that we're making, that is important. So while other distributed ledgers might use different methods, what sets blockchain apart is this idea of a chained structure of blocks. Finally, since every node keeps its own copy of the ledger, they all work together to agree on which chain of blocks is correct, is actually the valid one as the new data keeps coming in. And that is how your DLT systems operate, through direct communication, proposal of transactions, consensus mechanisms, and synchronized copies across all nodes. And blockchain, it actually makes this even stronger with its block linking approach that is done through cryptography. I hope you're able to relate to this back. Then what are your DLT actors? That is what we're going to study in the next slide. So you can see all the names here: user, node, service provider, and so on so more. So now we know what DLT is, right? And how it operates. Now let's just talk about what are its actors, what are its components that are going to make the system work. So first and foremost, we have your nodes. And a node is actually nothing but simply an individual system in the network. Some nodes are called full nodes. Then you have the other nodes as well, and we'll be taking one each, right? So the full nodes, they go extra mile. They store entire ledger, and also they pass the information to other nodes, and also they validate every new block that is getting added. Just to give them a name, they're actually the gatekeepers of your network. Next, we have your service providers. These are actually the components that offer DLT based services. They provide information, they provide interfaces so that other parties can connect and can actually make use of the distributed ledger. Then comes your users. A user is any participant who actually consumes or uses the services that are provided, right? And then there's this important point, hook point. A component in the system can sometimes be both. It could also be a provider of a service in one context, and it also could be a consumer in another. It also could be a user in another. That is it. And then we have user groups. User groups are nothing but they're simply the sets of users who are actually, who actually come together because they have a common purpose. I hope you're getting it. And finally, at the center, we have a distributed ledger. Distributed ledger is nothing but the validated consensus driven digital information that's stored, that's replicated across all the different nodes. So if I just want to sum up this slide to you, I would say nodes keep and validate data. Service providers offer DLT based services. Users are the ones who consume those services. Groups are where the users are organized as per their purpose, and the distributed ledger is actually the heart of DLT. Secure record that everyone wants to share, everyone wants to use. And all these components together create a trustworthy, decentralized system. So let's come to the uses of DLTs. The first one, it goes by recording transactions. So at its core, obviously, DLT is a ledger and ledger has no work else to record the transactions. So naturally, one of its primary use is recording inflows, recording outflows, much like a financial bookkeeping thing, record keeping thing. But here's the interesting part. It's not limited to money. It can also be used in smart contracts, transfer of digital assets, medical data updates, or the supply chain steps, right? Second, let's come to securing identities. Another powerful application that comes with DLT is digital identity. With DLT, individuals can have a secure tamper-proof identity, and this makes it much harder for the bad actors to commit identity theft, while giving people a reliable way to verify who they are online. Collecting votes, you can just go ahead, ensure fairness, prevents voter frauds, and builds trust in the democratic processes. Entering contracts, that is your smart contracts, agreements that execute automatically when certain conditions are met. For example, you getting an insurance payout if your flight is late. That application we have already started before in the previous video lectures. Then demonstrating ownership, DLT can be used to record property ownership, whether that's land, houses, digital assets like NFTs and everything. So far and so more. So now you understand DLT isn't just about cryptocurrency. It's about trust, it's about transparency, automation across industries like finance, healthcare, voting, insurance, and property. So now let's take a closer look at the features of DLT. These are the qualities that make it so powerful, so different from your traditional systems. Starting with first, decentralized. This word I think I've been speaking since the start of this video series. So, first and most importantly, DLT is decentralized. This means there's no single authority controlling the ledger. Every node maintains its own copy. If any update change happens, it gets reflected across all nodes, often within the seconds. Then immutable. Secondly, DLT is immutable. Once there is data in the ledger, you cannot delete it. You cannot change it. You cannot tamper with it. And that is what is ensured by cryptography. Append only. This brings us to the third feature, append only. New data can only be added, not edited, not deleted. Distributed, it's completely decentralized, completely distributed across all the nodes, not stored on any central server, not managed by any central authority, right? Efficient, and finally efficiency, because it's distributed and consensus driven. Transactions can be processed and settled within seconds, much faster, much efficient than traditional financial systems. Next, shared, not owned by any single authority, not owned by any single entity, not managed by a central authority, not stored at a central place, just shared across all the nodes, across all the participating nodes in the network. Smart contracts, DLT isn't just about recording transactions, it is also about how you act on them. Agreements are directly written into the code with the help of smart contracts, and they just execute automatically when the conditions are met. You don't have to go in, check in everything, because it's automatic then. Just like I told you before, also, right? Insurance payout if your flight is actually late. So simple. Fault tolerance, because it is decentralized, it is highly fault tolerant. Transparency, everything is there on the chain, so it's entirely transparent. Security, with cryptographic, with all those highly advanced security technologies, this is just so fault tolerant, so much secure, impossible to alter the information that's there once. I think this lecture is already being a little long. I'll just end it up with this slide. Types of distributed ledger technologies. We go by permissionless, we go by permission, and then we take the best of the both worlds and make it hybrid. So permissionless DLTs are open to anyone who's validating blocks without needing permission from any authority. Users are not required to obtain permissions to maintain and operate permissionless distributed ledger systems. Its systems are often implemented using open source software that is open to use for everyone, freely available to anyone who wishes to download it. Permissioned are the ones which require permissions. Users validating blocks must be authorized in permission distributed ledger systems. Since only the authorized nodes are maintaining the distributed ledger, it is possible to restrict read access and to restrict who can issue transactions. Hybrid, taking best of both the worlds, combine the privacy benefits of a permission distributed ledger system with the security and transparency benefits of a permissionless distributed ledger system. This gives business significant flexibility to choose what data they want to make public and transparent, whereas where do they have to keep it private and a little restricted from the open public. So that's it. If you have any doubts, if you have any concerns, if you think it was just a little too fast, just go in, write in the comment section, write in the G forms attached, and I'm going to take actions upon it, right? So yeah, if you liked in the video, if you were able to understand a lot, just go in, like the video, and subscribe to the channel. Thank you. Bye bye.